Chemical thermodynamics. The last lecture we have discussed about introduction of chemical thermodynamics, terms involved in the chemical thermodynamics, as well as limitations of the thermodynamics. The terms involved in the thermodynamics contains there is a three terms: system, surrounding, and universe. Also, we have to learn about the types of the systems depending upon the transfer of matter and energy between the system and surrounding. There are three types of the systems are already discussed. Today we have to discuss about the properties of the system. There are two types of the properties. First is the extensive property and second intensive property. Extensive and intensive, these two words can decide the property of that system. The first property is extensive property, and this extensive property is defined as the property which depends on the amount of matter present in the system is called as a extensive property. Means the property depends on the amount of matter present in the system is called as an extensive property. Just see a definition. For example, mass, volume, internal energy, heat capacity, and number of moles. In this case, keep this mass 1 gram, 2 grams, 3 grams, 1 kg, 2 kg. This mass is different and that depends upon the amount of matter. This depends upon the amount of matter present in the system. Next one is the volume. 1 liter volume, 2 liter volume, 3 liter, etc. And this volume increases with the quantity increases. Internal energy, this is the energy present associated with the substances. This energy is different in different substances. Therefore, mass, volume, internal energy, heat capacity, and number of moles are the extensive property which are depends on the amount of matter present in the system. Second is intensive property. Intensive property which is depends on the amount of independent on the amount of matter. This is independent on the amount of matter in the system is called as an intensive property. For example, there is a pressure, second density, temperature, surface tension, viscosity, melting point, boiling point, specific heat, etc. Suppose the temperature of 1 liter solution and is 10 degree, and another solution there is a 100 liter solution, there is also temperature is same. The temperature does not depends on the amount of matter. This is independent. Second is the density. The density of 1 ml water as well as 1000 ml water is also same. Density is not changed because there is a density can be carried out by using the volume, mass upon volume formula. Then density is also intensive property. Similarly, pressure. Next is the viscosity, melting point, boiling point, and specific heat. They are independent on the amount of the matter. They does not depends on the matter. Therefore, these are the examples of an intensive properties. The next point is a state function. The state function is the property of the state of a system. It is a property of a system. Definition of the state function is the property which depends on the state of the system and independent on the path followed to attain it is called the state function. Means the property depends on the states of the system and independent upon the path of the system is called as a state function. If the certain amount of the gas enclosed in a cylinder fitted with a movable piston, then there are some observations are observed. These observations are the first, supposed to pressure of the gas is 1 bar, this is the P1. Volume is 1 dm cube, this is the V1, and temperature is 300 Kelvin, that is of the path function. The property which depends on the path of the system are called as the path functions. For example, work and heat. This work and heat are depends upon the path of the system but not on the initial and final states of the system. Therefore, work and heat is an example of an path function. Thank you. This topic we discuss properties of the system, state function and path functions. Thank you.